Hello, everyone. Welcome to Physics 205, Physics for Movement Science. In this video, I want to talk about some physical quantities that are used in the study of physics and their associated units. And in particular, I want to discuss how to convert between different sets of units. Okay, so first of all, there are basically three physical quantities that are used in the study of mechanics, and these are time, length, and mass. These measurements, of course, are expressed in different units, and there's many systems of units that can be used in physics. There's the SI unit, right, which is System International, or it's also called the MKS unit. MKS stands for meters, kilograms, and seconds. There's the CGS set of units, which stands for centimeters, grams, seconds. And then there's also the English, or sometimes it's called the US customary set of units. In this class, we're going to use all three of these systems, but we're going to focus mostly on SI units. Okay, occasionally in lab, we will use CGS units as well, but most of the time we will be using SI units, which is really the standard for science and research throughout the world. Okay, so in this table here, I have the three quantities, time, length, and mass, and then what the actual units are in each of those systems. So in the SI system, time is going to be in seconds. So that's the unit for time in the SI system. The unit of length is the meter, right, abbreviated by M, and a unit for mass is the kilogram, abbreviated by kg. For the CGS set of units, time is again in seconds, again abbreviated by S. The length is in centimeters, abbreviated by cm, and the mass is in grams, abbreviated by a G. And then the English or US customary units, time again is seconds, right? So it's seconds for actually all three different sets of units for the unit of time. Length is the foot, abbreviated by FT. And then mass is the slug, which has no abbreviation to it. Now, these particular units have very particular definitions. And if you're interested, you can look at our textbook in section 1.2, and you can see how these various units are defined. Okay, let me first give you sort of the difference between what's called the fundamental versus derived units. So again, in the SI system, just what we observed from that table above, the fundamental units used in mechanics are the second, right, for measurement of time, the meter for the measurement of length, and the kilogram for the mass. Other physical quantities, which are basically called derived quantities, can be expressed as algebraic combinations of time, length, and mass. And these new quantities have new units, right? They're called derived units, as opposed to the fundamental units, right, of second, meter, and kilograms. So here's what I mean. Here are some examples of that, of derived units. So speed would be a derived quantity. It's basically the length divided by time. But remember, the fundamental unit of length is meters. The fundamental unit of time is seconds. So this new combination of meters over seconds, meters divided by seconds, that is a derived unit, right, for speed. Also for velocity as well. So meters per second is a derived unit for speed. Another example you can see here is acceleration, which is really speed divided by time, or another way of writing this is it's length divided by time squared. So again, remember the fundamental SI unit for length is meters. The fundamental unit for time is seconds. So in this case, this derived set of units is meters per second squared, right? That would be the units for acceleration. And then for the last example, if we look at force, and we'll talk a lot about force in future lectures, Force is defined as mass times acceleration. But remember, mass is measured in kilograms and acceleration is meters per second squared. So if I multiply those units together, I get kilograms times meters divided by second squared. So that is the derived unit for force. Now it's so common, that set of units, kilogram meters per second squared. It has its own name. It's called the Newton. So that N there, the capital N, stands for Newton. So we really would say that Newton is the derived unit for force, right? It's equal to that combination of kilograms times meters divided by second squared. Okay, now what I really want to focus on in this lecture is conversions, how to convert from one set of units to another set of units. So we're often going to need to be able to convert from one set of units to another. So we can do this, and this is the most common way of doing this, is by multiplying something called a unit conversion factor. So we use these unit conversion factors to convert from one set of units to another set of units. Okay, so I'm going to jump on the iPad and do a bunch of examples where I show you how to do these conversions. Okay, so conversions. All right, so let me start by giving you some basic English units of length. Actually, I'll just make a little table here. So we know that 1 foot, which I'll abbreviate as FT, is equivalent to 12 inches, right, which is IN. We know that 1 yard, abbreviate as YD, is equivalent to 3 feet. And we know that 1 mile, so MI, is equivalent to 5,280, right? 5,280 feet. Okay, so let's start off simply by using these unit conversion factors to solve some problems. Okay, so first of all, if I write, let's say I write 12 inches is equal to 1 foot. Notice that I can divide both sides by 1 foot. And on the right-hand side, everything cancels. So I get 12 inches over 1 foot is equal to 1. Okay. I could have also divided both sides by 12 inches. Let me write this again. 12 inches equals 1 foot. I'm going to divide both sides by 12 inches. Now everything cancels on the left side, right? It's anything over itself is equal to 1, including the units. This is 1. So that's equal to 1 foot over 12 inches. Now, these ratios here, so the 12 inches over 1 foot, which is equal to 1, or the 1 foot over 12 inches, because they really represent the same length, right? So that ratio, that's why it's equal to 1. These are called unit conversion factors. Okay, so we can use these to convert from one set of units to another set of units. So let me give you an example. Let's say I want to convert 4.5 feet to inches. Okay, so I start with 4.5 feet, and I want my result ultimately to be in inches. So the way I do this is I write what I'm given. So I'm starting with 4.5 feet. I want to multiply by some unit conversion factor. Okay, so the second term here is going to be some unit conversion factor. And then I want my answer to be something, but the units will be in inches. So IN for inches. Now remember, what's the relationship between feet and inches? Well, we know that we have 12 inches over 1 foot, or the other way we could write this is 1 foot over 12 inches. Okay, those are both unit conversion factors. One of them is going to be helpful in this case if I want to convert from feet to inches. The other one will not be helpful in this case. So the question is, which one, let me fix this writing here. Which one should I use? Should I use 12 inches over 1 foot, or should I use 1 foot over 12 inches? Which one should I multiply by so I convert from feet to inches? So the way to think about this is I want my units of feet to cancel, right? So feet, I want to cancel. In order for them to cancel, I need to have feet on the bottom in the denominator here for my unit conversion factor. And I want the units of inches to survive in the answer, right? To end up in the answer over here. So if you think about that, I need to multiply by 12 inches over 1 foot. Again, why did I do that? Because I want feet to cancel. So feet will cancel with feet. And then the inches will end up in the answer over here for inches. Okay, so now that I know I multiply by 12 over 1, I can complete the problem, right? So the way you would do this, think of it as fractions. You have 4.5 over 1 times 12 over 1. So I multiply numerators. If you multiply 4.5 times 12, you can do this on a calculator. You're going to get 54. And then 1 times 1 is 1. So this is just 54. But now I have the correct units of inches, right? The feet cancel, and I end up with inches. Inches ends up in the answer here. So 4.5 feet is the same as 54 inches. Okay, here's another example. Let's say I want to convert 45 inches to feet. Okay, so I start with 45 inches. I want to multiply by some unit conversion factor, and I want my answer to be in units of feet. So now I want inches to cancel, and I want feet to end up in the answer, right? So now inches in my unit conversion factor has to be in the denominator, and feet has to be in the numerator. So in this case, instead of using 12 over 1, I need to use 1 over 12, right? I want to multiply by 1 foot over 12 inches. So again, inches will cancel and feet will remain in the answer. So to complete this problem, right, again, you can think of this as fractions. I have 45 over 1 times 1 over 12. And then if you work this out, right, you're going to get, let me just multiply numerators. 45 times 1 is 45. 1 times 12 is 12. If I divide that out on my calculator, I'm going to get like 3.75. I'm going to round to 1 decimal place. So this is going to be 3.8, right? So 45 inches is 3.8 feet. Okay, 3.75, but I'm going to round to 3.8. Okay, here's another example. Let's say I want to convert 194.4 inches to yards. Okay, so I have 194.4 inches. That's what I started with. And I want to convert to yards. Now, it turns out in this case, I could actually do this conversion with just a single unit conversion factor. If I know the relationship between inches and yards, turns out there's 36 inches in 1 yard, so I could do this directly. But often it's maybe easier to use multiple unit conversion factors. So for instance, I could first go from inches to feet, right? So if I want inches to cancel and feet to remain in the numerator, then first I would start with 1 foot over 12 inches. That'd be my first unit conversion factor. But now if I were to stop there, I'd have my answer in feet. I want to go actually to yards. So now I need to find a relationship between feet and yards. Well, I know there's 3 feet and 1 yard. I want feet to cancel. So I'm going to put the 3 feet in the denominator and then 1 yard in the numerator. And you can see here, inches cancels, feet cancels, and I'm going to end up with yards, right? I end up with yards and yards, which is what I want. So now again, to complete this, I just need to do this multiplication out. So if I multiply, I'll write this as 194.4 over 1 times 1 over 12 times 1 over 3. So this is going to be 194.4 over 36, which is equal to around 5.4. We'll talk more about significant figures in a later video, but if let's say I'm starting with 4 significant figures, I want my answer to have 4, then I'd write this as, I just add 2 zeros to it. So it would be exactly 5.400. But if you write 5.4, that's fine. So 5.400 yards. Okay. Now again, if you wanted to, you could have, let me just show you this quickly. You could have just used a single unit conversion factor if you know the direct relationship between inches and yards. Again, there's 36 inches in 1 yard. So I could have multiplied by 1 yard over 36 inches. Right now, inches cancel, I end up with yards. And again, I'm going to get 5.400 yards. So if you know that, it can be quicker, but sometimes it's easier to use multiple unit conversion factors, several in a row, okay? Especially if you don't know the direct relationship between those 2 units. Also, you may notice here that when I multiplied these 2 together, right? See how 1 times 1 is 1 and 12 times 3 is 36. So really this combination gives me the 1 over 36, 1 yard over 36 inches. Okay, next, let's talk a little bit about the metric system. Okay, so what's special about the metric system? Well, first of all, it's based on powers of 10. So that's useful, right? It's easy to multiply by powers of 10 or divide by powers of 10. It's basically moving the decimal point. And there's only a single unit for each quantity. And by that, I mean, let's say we're measuring length using the metric system, then the unit, like the base unit, is meters, right? So a meter. If we're working with mass, then it's gram. Volume, it would be liter, and so on and so forth. Now, if we want larger or smaller powers of 10 of these units, of these lengths, masses, and volumes, then that's when we use prefixes. So prefixes are used to represent larger or smaller powers of 10. Okay, so what are these prefixes? Well, let me write this out. So again, let's say, since we're talking about length right now, let's just stay with length. So I'm going to write 1 meter, which remember is abbreviated as m, is equal to 1 meter. Okay, if I want to represent something that's 10 times the length of 1 meter, that's called a decameter. So 1 decameter, so D-E-K-A meter, it's usually abbreviated as D-A-M, is equal to 10 meters. If I want another power of 10, right, so 10 times 10, 100 times a meter, that's called a hectometer. And that's abbreviated as HM. So that's equal to 100 meters. And then if I want 1,000 times a meter, you're probably familiar with this one. This is called a kilometer or kilometer. So kilometer or km. So that'd be equivalent to 1,000 meters. Now going the other way, if I want 1/10 of a meter, that's called a decimeter. That is just abbreviated as dm. So that'd be 1/10 of a meter. Or another way of saying this, all right, or here, you could say there's 10 decimeters in 1 meter. So 10 decimeters is equal to 1 meter, right? That's the same as saying 1 decimeter is 1/10 of a meter. So 10 decimeters would be equal to 1 meter, right? In fact, to get that, I can multiply this side by 10, this side by 10, right? So I get 10 decimeters, and then 10 times 1 over 10 is equal to 1 meter. And then 1/100th of a meter, again, this one you're probably familiar with, is a centimeter. So abbreviated as cm. That'd be 1/100th of a meter. Or another way of writing that is, you could say there's 100 centimeters in 1 meter, right? So 100 centimeters equal to 1 meter. And then finally, 1,000th of a meter is called a millimeter. So 1 millimeter, which is abbreviated as mm, is equal to 1 over 1,000, right? 1,000th of a meter. Or we could say that there's 1,000 millimeters in 1 meter. Okay. And of course, if we wanted to talk about mass, right, grams, then we would just replace the center one here with grams, right? So 1 gram is 1 gram. And if we want 10 times a gram, that'd be a decagram, right? If you want 1,000 times a gram, it'd be a kilogram. So it's the same exact prefixes, except the unit, right? In this case, now we want mass, grams, instead of length, meters. So we just replace meter by gram. Or if we're talking about volume, then it'd be a liter, right? So if we want 1,000th of a liter, that would be a milliliter, and so on and so forth. Okay, so let's talk about a little bit about conversions within the metric system. So for example, let's say that I want to convert 7.2 centimeters to millimeters. Okay, now again, we can always use unit conversion factors. They will always work. We'll see in a second, as long as we know that we're within the metric system, there is an easier way to do conversions, and I'll show you that in a minute. But let me first show you unit conversion factors, because unit conversion factors will always work. So first thing, I'm starting with 7.2 centimeters. I want to multiply by a unit conversion factor, and I want my answer to be in millimeters. Okay, so I need to figure out what the relationship is between centimeters and millimeters. What is that relationship? Well, if we go back, let me go back to the previous page for a second here. So we know, right, that 1 centimeter, look at centimeter here, since it's like one spot above millimeters, it's 10 times as large as a millimeter, right? So 1 centimeter is 10 times as large as a millimeter. Because if I jump up by one, these keep increasing by 10 times, right? The previous unit. So I know that, again, 1 centimeter is 10 times as large as a millimeter. So another way of saying that is I can say that there's 10 millimeters in 1 centimeter, right? If 1 centimeter is 10 times as large as a millimeter, then I could fit 10 millimeters in 1 centimeter. So that's my unit conversion factor. Now I can either write this as 10 millimeters over 1 centimeter, or I could write it as 1 centimeter over 10 millimeters. If I want to convert from centimeters to millimeters, which one do I use? Well, I want to use the one where centimeters is in the denominator because I want it to cancel, right? So I'm going to use that first one where I have 10 millimeters over 1 centimeter. So now if I multiply, notice that centimeters cancel. I'm going to end up with millimeters in my answer. And if you work this out, this is 7.2 over 1 times 10 over 1. So this is going to be, if you do 7.2 times 10, that's 72 over 1, which is just 72. So this is going to be 72 millimeters. Okay. And notice here that ultimately all I ended up doing was moving the decimal point one place to the right, right? One position to the right, because I'm just multiplying by 10. Okay, so if you notice that, right, in fact, moving anywhere on this table, we're going to really just multiplying by a factor of 10. So that really means just moving the decimal point either to the right or to the left. So this is sort of an easier method I'm going to give you now, where if you want to do conversions within the metric system, but it has to be within the metric system, then you can use this, this shortcut here. So I'm going to write out this table again. So this table right here, but I'm going to write it horizontally. Okay, so what I'm going to do is I'm going to put meters in the middle, right? That's our base unit for length. And then to the left, I'm going to do the larger units, right? So remember, 10 times a meter was a decameter. Then 100 times was a hectometer, HM. And then 1,000 times was a kilometer. And then to the right, if I do 1/10 of a meter, remember that was a decimeter, DM. Then a 100th of a meter was a centimeter. And then 1,000th is a millimeter. Okay, so now let's say I want to convert, do another example here, convert 7.33 hectometers to decimeters. All right, so I start with 7.33 hectometers, and I want to end up with the units in decimeters. So how do I do that? Well, in this case, with the shortcut, I start on the table at hectometers, right? Because I'm beginning at hectometers. So I'm starting right here. Now the question is, what do I need to do on the table to get to decimeters? Well, if I start at hectometers, I need to move 1, 2, 3 places to the right. So it turns out whatever you do on the table, so in this case, I move 3 places to the right, I need to do the same thing to the decimal point in the number. So if I'm moving 3 places to the right, that means I need to move this decimal point 3 places to the right, right? Which means I need to add a 0, right? So this would be 7330. And that's my answer. So 7,330 decimeters is the same as 7.33 hectometers. Okay, here's another example. Let's say I have let's say I want to convert 83.42 centimeters, and I'm going to convert those to kilometers, right? Kilometers or kilometers. Okay, so I'm starting with 83.42 centimeters, and I want to end up in units of kilometers. So if we look at our table, what do I need to do? So I'm starting at centimeters, and I want to get to kilometers. So it looks like I need to move, let's see, 1, 2, 3, 4, 5 places to the left on the table. So what do I need to do to my number here? I need to move the decimal point 5 places to the left. So let me write it again, 83.42. So I'm going to move that decimal point 1, 2, 3. I need to add a 0, 4, another 0, 5. So then my answer will be a 0.0008342. And you can always write a 0 in front if you want. Okay, so 0.0008342. Okay, did you understand that? So whatever you have to do to the table to get from the units that you have to the new unit, you do the same thing to the decimal point. Okay, so in this case, again, I moved the decimal point 5 places to the left. In the previous example over here, I moved the decimal point 3 places to the right. Okay, so if you're within the metric system, that is a quick way to do the conversion just by moving the decimal point. But for anything else, you really want to use unit conversion factors. And actually, in the next example, you really have to use unit conversion factors. Let's say we want to convert between metric and English units. So I'll just write, you must use unit conversion factors to convert between metric and English units. Okay, now there is a nice thing that you guys should know actually to go from English to metric units, and this is exact. It's the fact that 1 inch is exactly equal to 2.54 centimeters. So that's kind of like the bridge to go from English units to metric units when we're talking about lengths. So 1 inch is equal to 2.54 centimeters. You should probably memorize that. It's really useful. Okay, so here, let me do an example using this. Let's say I want to convert 4 feet and I want to convert 2 meters. Okay, so I'm starting with 4 feet. And ultimately, I want to end up in meters. And let's say the only thing I know, I mean, you could look this up online and figure out a direct conversion from feet to meters. But let's say I just know that 1 inch is equal to 2.54 centimeters. So how can I use that knowledge to get from feet to meters? Well, there's a few other things I need, right? I somehow need to go from feet to inches, right? In order to use this knowledge here of 1 inch equals 2.54 centimeters, I need to somehow convert this to inches first. Well, we know how to do that, right? We know that there's 12 inches in 1 foot. So the first unit conversion factor I could use is I can multiply by 12 inches over 1 foot. Again, why do I do that? Because I want feet in the denominator, so it cancels with the feet from the 4 feet. Now that I'm in inches, I can use this new knowledge here, this new unit conversion factor, and I can write this as 2.54 centimeters over 1 inch. Okay, so now inches cancel. Let me just cancel. So feet canceled. Now inches cancel. So if I were to stop right there, my answer would be in centimeters. Okay, but I want to go all the way to meters. You could actually stop there, get the answer in centimeters, and then move the decimal point, right, to go from centimeters to meters, since it'd be within the metric system. But I'm going to use just another unit conversion factor. Well, I know that there are 100 centimeters, right, in 1 meter. So if I multiply by 1 meter over 100 centimeters, then centimeters will cancel and I end up with meters, which is what I want. So now if I multiply all this out, so I have 4 over 1 times 12 over 1 times 2.54 over 1 times 1 over 100. If you multiply this all out, you're going to get, and you simplify it, you're going to get 1.22. I'll assume there's 3 significant figures. So this is like 1.22 meters. So 4 feet is a little bit more than a meter, right? 1.22 meters. Okay, now, again, if you had known a direct conversion between feet and meters, you could use that. So let me just do that real quick. So let's say, same example, right? I'm going to go from 4 feet to meters. But let's say I look this up, maybe in the back of your book or online, and you find that 1 meter is equal to 3.281 feet. So if you know that, then I could just multiply by 1 meter over 3.281 feet. And why did I write it that way as opposed to 3.281 over 1 meter? Because again, I want feet to cancel, right? I want feet to cancel and I want meters to survive. And of course, if you multiply this out, you're going to get exactly the same answer, 1.22 meters. Okay, so sometimes you can use multiple conversion factors like we did here. Other times, if you know a direct relationship between the 2 units, between feet and meters in this case, you could use 1 conversion factor. It's really up to you how you want to do this. Okay, here's another example. Let's say I want to convert, I'm going to do a velocity now. So 70 miles per hour. I want to convert that to meters per second. Okay, and let's say I'm told that 1 mile is equal to 1.609 kilometers. Okay, so 1 mile is 1.609 kilometers. And I want to convert from miles per hour to meters per second. All right, so I'm going to start. And for this case, we're going to have to multiply by a lot of unit conversion factors. So I'll write this as miles per hour. And way over here, I'm going to hopefully end up with meters per second. Right, meters per second. Okay, so first, let me go. I want to somehow get from miles to length of meters, right? To units of meters for that length. So let me first use this new unit conversion factor. I know that there's 1.609 kilometers in 1 mile. So if I want miles to cancel and I want kilometers to remain, I need to write this as 1.609 km over 1 mile, right? Then miles will cancel. So right now I have kilometers, but really I want meters because I want meters to be in my answer, right? In my answer, I want meters in the numerator. So I need to go from kilometers to meters. Well, we know that there's 1,000 meters in 1 kilometer, right? So I can multiply by 1,000 meters over 1 kilometer. Okay, now we'll see here that kilometers cancel. So now I have meters in the numerator and I still have hours, right? We didn't do anything with this yet. I still have hours in the denominator. Ultimately, I want seconds in the denominator. So how do I relate hours and seconds? Well, first of all, we know that there's 60 minutes in 1 hour. So I could go from hours to minutes. Actually, let me do that first. So let's see, I want hours to cancel, right? And remember, it's in the denominator now. So that means I want to write 1 hour up here so that it cancels with the hours over there over 60 minutes. Right? Do you guys see how that cancels? So hours cancel. So now if I were to stop, I'd have meters per minute, but I want meters per second. So now I need a relationship between minutes and seconds. And I know that 1 minute is 60 seconds. So if I multiply by one more unit conversion factor, 1 minute over 60 seconds, then notice here that minutes cancel. And now I have the correct units of meters. I'll do this in blue. Meters over seconds, which is what I want, right? Meters per second. So now you need to multiply all this out, right? So this is like 70 over 1 times 1.609 over 1 times 1,000 over 1 times 1 over 60 times 1 over 60. So multiply it out and simplify it, and you're going to get, in this case, like 31.3. So it'll be 31.3 meters per second. So 70 miles per hour is approximately 31.3 meters per second. Okay. Now, again, let's say in your physics book, you looked up the relationship between meters per second and miles per hour. Sometimes they have direct relationships for speeds. And you found that 1 mile per hour was equal to 0.447 meters per second. Okay. So if you know that, then you could have done this in one step, right? If I start with 70 miles per hour and I multiply by, so now I want miles per hour to cancel. So that's going to be in the denominator and meters per second to be in the numerator. So now I'd multiply by 0.447 meters per second over 1 mile per hour. So actually, in this case, these in some sense cancel, right? And then you would end up again with the same answer. It'd be like 31.3 meters per second. So you could do it in one step if you know this relationship between miles per hour and meters per second. You could do it in one step. Sometimes you don't know that. Sometimes you have to do multiple steps like we did here, right? It doesn't matter. Either way, it will give you the correct answer. Okay, but you should really be familiar with both ways. Okay, what if, so we've been dealing with length, right? What if we're dealing with area or volume? How do you handle that if you want to convert from one area to another area, one volume to another volume? Let me give you one example here. Let's say let's say I want to convert 4 cubic yards. And the way to write that is yards cubed, right? So 4 yards cubed, same as cubic yards, to feet cubed, which we also say cubic feet. So I start with 4 yards cubed, and I want to ultimately go to feet cubed. Now we know the relationship between feet and yards, right? We know that there's 3 feet is equal to 1 yard. And since I want yards to cancel, I probably want to use the unit conversion factor like this, right? Write it as 3 feet over 1 yard. Okay, so if I multiply by 3 feet over 1 yard, you might think that's it, right? If I just multiply 3 feet by 1 yard, that'll give me the answer. But notice here that that doesn't quite work, right? We're not quite there yet because only one of these yards is going to cancel with one of these yards up here. So now I still have like yards squared. So how do I handle this? Well, I need to multiply by this same unit conversion factor another 2 times. So if I multiply by 3 feet over 1 yard again, and times 3 feet over 1 yard, then that yard cubed now cancels with these 3 yards in the bottom. So I have yards cubed over yards cubed, it cancels. And notice in the numerator now, if I multiply feet times feet times feet, I have feet cubed. Okay, so you have to make sure that in this case, you multiply it by that unit conversion factor 3 times. And if it was an area, then you have to multiply by it 2 times. So actually, let's complete this problem. So if I multiply 4 over 1 times 3 over 1 times 3 over 1 times 3 over 1, it looks like that's going to be what, 27 times 4, which is 108. So this is 108. So it's going to be 108. So 4 cubic yards is the same as 108 cubic feet. Okay, just a couple more examples, and then that'll be it for this video. Let's say you're told American football is played on a 100-yard long field. And all we want to know is how long is the field in meters? So how long is the field in meters? Oh, let me fix that word then. Okay, so I start with, I'm given that the length is 100 yards, right? I want to ultimately end up in meters. Okay, so how do I do this? Well, I first need to convert between, basically, there's several ways we could do this, right? Let's say we're given, here, I'll go a little further. Let's say we're given the fact that 1 meter is equal to 3.281 feet. We didn't need that. We could have actually done this using multiple unit conversion factors, but this will make it a little easier. In this case, we'll only need 2 unit conversion factors. So first, let me go from yards to feet. So to do that, right, I know that there's 3 feet and 1 yard. So I want to multiply by 3 feet over 1 yard. So again, yards cancel. If I were to stop there, I have my answer in feet, right? It'd be 300 feet. But I want to go to meters. Well, we were just given the fact that 1 meter is 3.281 feet. Again, which way do I write this? Well, I want feet to cancel. I want meters to remain in the numerator. So I'd write it as 1 meter over 3.281 feet. So now feet cancels, and I have my answer in meters, right? So if you multiply this out, 100 over 1 times 3 over 1 times 1 over 3.281 feet, you're going to get like 91.4. So a 100-yard football field is equivalent to 91.4 meters, right? That'd be the length of it in meters. Okay, so not too bad, right? Just converting from yards to meters. Okay, and then let me do one more problem. Let's say that we wanted to find a relationship between meters per second and miles per hour. Okay, so I mean, this is something you could look up, but let's say we want to derive it ourselves. So I'll say, what is the relationship between meters per second and miles per hour? Okay, and I'll do this as, I'll start with 1 meter per second, and I want to know how many miles per hour that is. Okay, so using what we just learned above, that unit conversion factor between meters and feet, let's use that first. So let me first go to feet. So if I multiply by 3.281 feet over 1 meter, right, meters will cancel. Okay, and right now I have feet per second. So I'm going to go a little further. I want to go now to miles, from feet to miles. So let me just continue with the length conversion. So again, what's the relationship between feet and miles? Well, I know that 1 mile, I want that in the numerator, is equal to 5280, right? 5,280 feet. So then feet will cancel. Remember, ultimately, my goal is to get this to be miles per hour. Okay, so right now, if I stop, I have miles per second. So I need to go from seconds to hours. Well, first, let's go from seconds to minutes. So if I multiply by, since seconds is in the denominator already, now I want to put seconds in my unit conversion factor in the numerator. So 60 seconds is 1 minute. So then seconds will cancel. And then I want to convert minutes to hours. Well, I know there's 60 minutes. Again, I'm putting that in the numerator because I want to cancel with minutes that's already in the denominator over 1 hour. And I want the hour to remain in the denominator. Okay, so now minutes cancels, and I have exactly what I want, right? If you look here, we have miles, everything else is canceled, over hours, right? That's exactly what we want. So if you multiply this out, so 1, you can write as 1 over 1 times 3.281 over 1 times 1 over 5280 times 60 over 1 times 60 over 1, you're going to find that this is equal to 2.24. So this is going to be 2.24 miles per hour. Okay, so now we know 1 meter per second is equal to 2.24 miles per hour, right? So that's our relationship between those two variables. Now, if we wanted to do, if we wanted to start with 1 mile per hour and see how many meters per second that is, we could actually do that using what we just found. Let me just show you a quick way of doing that. So again, we know that, let's see, we know that 1 meter per second is equal to 2.24 miles per hour. What if I divide both sides by 2.24? So now on the right hand side, right, 2.24 over 2.24, that's going to be 1. I still have the correct units there. So now I'm saying this is like 1 mile per hour is equal to, and on the left hand side, if I divide 1 divided by 2.24, I'm going to get like 0.447. So this is equal to 0.447 meters per second. Okay, so we have it both ways now. 1 mile per hour is 0.447 meters per second, or the other way, we knew that 1 meter per second was 2.24 miles per hour. Okay, so really conversions, this takes a little practice, but once you get the hang of this, it's a matter of multiplying by one or several unit conversion factors, okay? Unless you're within the metric system, then you can use that quick method of just moving the decimal point. And that only works if you're dealing with strictly a length or strictly a mass, right? If it's a volume or area, then it's a little more complicated. Okay, great. Thank you.